this second method was utilized by me in the case of the examples with the hydrochloric acid and alumina and zinc. But I will show you on this example, which is more complex and more difficult. Yes. So once again, copper and copper, and now we treat these elements not as an atoms, but as ions or particles, or atoms if they stand alone. Yes. So oxidation reaction. Here we have it. Oxidation reaction. Okay, I will write it properly. Okay, oxidation reaction. Copper from the metallic state to copper as an cation with that charge to plus 2 electrons. Okay. Okay, so balance of matter is correct. Yes, one atom of copper, one atom of copper cation. The balance of the charge is also correct. 0 on the left side, 0 on the right side. 2 plus 2 minus give us 0. Okay. Reduction reaction. Okay. And here we can't take hydrogen atom. I'm sorry, nitrogen atom. We need to take particle in which this nitrogen atom exists. This reaction undergoes in aqueous electrolyte, in aqueous solution. So, in this solution exists, in the case, of course, in the nitric acid, exist hydrogen cations and nitrate anions. Nitrogen is contained in nitrate anion. So we need to take nitrate anion. So what else? The same situation in the case of the products. The nitrogen that change his oxidation state exists in I will make some space. Okay, this nitrogen exists, of course, in nitrogen dioxide. Okay. What should we do? The next step is to fill the number of electrons. You remember that the oxidation state of nitrogen in the nitrate is equal to +5. In the nitrogen dioxide, +4. So this particle gain 1 electron. Okay. What else? Let's check the balance of matter. On the left side we have 1 atom of nitrogen. On the right side also. Okay, so it is correct. On the left side we have 3 atoms of oxygen. On the left side we have 2 atoms of oxygen. So it is incorrect. Let's check the balance of the charge. On the left side the net charge is equal to -2 because we have 1 electron and nitrate anion. On the left side the net charge is equal to 0 because we have a neutral nitrogen dioxide particle. So it is also incorrect. What should we do? Okay, let's remember that this reaction proceeds in aqueous electrolyte solution. So, besides hydrogen ions from nitric acid and nitrate ions, there are also water particles and hydroxide ions and hydrogen ions which comes from auto-dissociation of water particles. Yes, here we have a acidic solution. Yes, so there is a lot of hydrogen ions, then water particles, and the less is the less amount of hydroxide and ions. Okay, so let's check it. We have H plus, water particles, and hydroxide anions. These three types of particles. Yes, the highest charge is indicated by the hydrogen ions. This charge is equal to plus 1. Then water particle, which is equal to 0. And then hydroxide anions. The charge of this particle is equal to -1. So it is the lowest from all of these three particles. So depending on the pH of the solution, we are choosing always two types of particles, H plus and water, or water and hydroxide anions. And which pair we will choose depends on the pH of solution. This solution pH is acidic, so we are choosing H plus and water particle for this example. Yes, H plus and water particle. Okay, I will make it clear for you. Okay, so to balance the mass of this reduction reaction and the charge, we need to use hydrogen, cations, and water particles. Let's remember that we use the particle with the higher charge on the side with the electrons, because it will allow us to balance the charge. Yes, so on the left side in the reduction reaction we have electrons on the left side, so here on the left side we need to put hydrogen ions. So here on the right side we need to put water particles. Okay, so let's check it. On the left side we have one atom of nitrogen, on the right side also. On the left side we have 3 atoms of oxygen, on the right side also 3 atoms of oxygen. So it is correct, it is clear. What about the hydrogen atoms? On the right side we have 2 hydrogen atoms, on the left side we have only 1. So we need to put 2 in the front of hydrogen cation. Let's check it. Let's check the charge. On the right side, the net charge is equal to 0 because nitrogen dioxide and water particles charges are equal to 0. Those are neutral particles. On the left side, we have an ion with the charge equal to -1. We have 1 electron, and we have 2 hydrogen cations with the charge equal to plus 1. So the whole give us charge equal to 0. -1 plus -1 give us -2, plus 2 plus give us 0. Okay, what is the next step? In the next step, we need to balance the whole reaction. We need to balance the number of electrons. In the oxidation state, we have on the right side of the reaction 2 electrons. So these 2 electrons need to be consumed in the reduction reaction. So we need to multiply this reduction reaction by 2. So we are obtaining then 2 nitrate anions plus 2 electrons plus 4 hydrogen cations, and we are obtaining 2 nitrogen dioxides and 2 particles of water. Okay, so now we could write the total overall reaction. 1 atom of copper plus 2 atoms of nitrate anion plus 4 hydrogen cations give us 2 particles of nitrogen dioxide plus 2 particles of water. Once again, please be aware that this overall reaction concerns only specimens that take part in redox reaction, so specimens that change their oxidation states. So we can fulfill now the coefficients of the main particle-like reaction. Copper atom and copper salt, of course, there is only 1 atom and 1 particle of the salt, yes? We have 2 nitrate anions that take a part, yes? We are not sure how many anions are on the left side, but we are sure that all of the nitrogen dioxide take part in this redox reaction. So we can write 2 in the front of nitrogen dioxide. Okay, what else? We could sum up the nitrogen atoms. On the right side we have 4 nitrogen atoms. So on the left side we could write 4 in the front of nitric acid. And it's correct because in the overall below reaction we have 4 H plus ions. Okay, so what else? Particle of water. Here we have 2 water particles and we put 2 in the front of water particle. It could be confusing for you because I said that in this reaction here below at the bottom there are only specimens that take a part in redox reaction. However, there are also such specimens like water and hydrogen ions. They do not change their oxidation state, however, they took a part in the whole reaction, yes? Because nitrate anion lose one of the atoms, and this atom is attached to hydrogen ion to create water particle, yes? They do not take a part, but they are a part of the specimens. It could be for you confusing, but I think that when we will proceed, when we will perform another examples, it will be, I'm sure that it will become for you very, very clear.